everyone. For an arithmetic sequence, with our third term is -5 and our eighth term is 40, we're going to find the sum of this sequence. I forgot to type that in. Find the sum of the sequence with these absolute values. So the first thing we need to do is find a sub n. And to get our formula for our explicit formula, so basically let's look at these two and solve for those. A sub 3 is going to equal, and this is your formula, a plus n minus 1 times d. So that's going to equal your first term plus 3 minus 1 is 2d. And then for your eighth term, that's going to be a plus 7d. Now this equals -5. The second equation equals 40. So we'll call this equation 1, equation 2. Now if you take 2 and subtract 1, we're going to get 5d equals 45. That means our d equals 9. And if you substitute back in 9, you're going to get a equals -23. So your explicit formula is going to be equal to your -23 plus 9 minus 1 is 8 d. Let's just put 9 minus 1 and then d is 9. So this is going to equal 9n minus 32. So this is the explicit formula that we will be using. All right. Now, let's look for when a sub n is 9n minus 32 and when it is positive. And we're doing that because we have these absolute value signs. So when it's positive, we're going to get n is greater than 32 divided by 9, which equals 3 point something, 27 and 5/9, right? Wait, 27. Yeah, 5/9. So what we want to look at is what this means, because we have just integers here. So we have 3 and 5/9. So if n is greater than or equal to 4, that means, because we have to round up, that means our a sub n is positive. However, when n is less than or equal to 3, that means our a sub n is going to be negative. All right. So how we can rewrite our equation is, instead of absolute value signs, I can write my first three terms as negative. That would be a sub 1 plus a sub 2 plus a sub 3. And then my next four terms are going to be positive. So that's going to be a sub 4 plus a sub 5 plus all the way to a sub 20. All right. Now that we have that, let's rewrite this because we want to use this formula here. So if I write all of this, say a sub 1 plus a sub 2 plus a sub 3 plus ... plus a sub 20, to make this equal this one, which is what we have, what I can do is I'm going to take this and subtract my a sub 1 plus a sub 2 plus a sub 3, and then also subtract it again. So it's another minus a sub 1 plus a sub 2 plus a sub 3. Because what I did is I added this, so I have to subtract it back out. So I'm trying to make these two look the same. So basically simplifying this gives me a sub 1 plus a sub 2 plus a sub 3 plus ... plus a sub 20, and just add those two together. So it's going to be minus 2 times a sub 1 plus a sub 2 plus a sub 3. All right, now I can use my formula here, given here. So basically what we're going to have is, for this piece, we're going to have the sum of the first 20 terms is going to be 20 times n is divide by 2, and then we have 2 times your first term. And let's not forget we have a sub n equals 9n minus 32. So that was our explicit formula. So basically your first term for this is going to be negative 23. And then you plus 20 minus 1 times your common difference, which is 9. Common difference is always this formula here. All right. And then you take this part, and this is going to be minus 2, and I'm just going to substitute in 1. So if I substitute in 1 into this formula, I get negative 23. If I substitute 2 into the formula, I get negative 14. If I substitute 3 into this formula, I'm going to get negative 5. And that's your common difference is 9 again. So this one I just substituted in the values. So this is going to end up being, this is 10. And when you simplify all this, you're going to get 1,250. And then you're going to have minus 2. And this is going to be negative 42. And then when you simplify all that, you're going to get 1,334. And that's your sum of the sequence. Thank you. Have a nice day. Bye-bye.